This tractor bearing in front of us has developed cracks, but they would still choose to repair it in Pakistan. With just their simple welding and machining techniques, the entire surface shows no signs of repair. The tractor owner in Peshawar wanted to cut costs, so he decided not to replace the damaged bearing. He went to a reputable local repair shop. After a simple rotation test, the master found that the inner ring of the bearing had not only cracked and expanded, but the displaced balls had also cracked the outer ring. Fortunately, the fracture surface had not fragmented, making the overall repair rate 100%. Since both the inner and outer rings required welding and the balls needed to be removed, the master first cut the outer ring. An angle grinder quickly separated the internal balls with a quick cut. Due to the cage holding the balls in place, the master used a screwdriver to pry the balls out, creating enough space to remove the inner ring. A thorough cleaning with diesel was necessary to ensure no dirt remained on the surface. After a quick wipe down, the master reassembled the cut outer ring. The cutting had altered the internal diameter, so iron pieces were used to fill the cut, restoring the original diameter. To minimize the gap in the crack, the master used a clamp. Since the gap was too small to weld on the surface, he cut and ground a bevel to increase the welding area. With simple build-up welding using a welding rod, the cut surface was clamped tightly. Even after removing the iron filler, the outer ring remained stable. The surface crack was cut and widened with a saw blade to ensure welding strength, and a groove was ground out. Once both cracks on the outer ring were welded, a second weld was required for the inner ring. When the raised weld scars affected the installation of the balls, the master did not falter. He used his problem-solving skills to grind the weld scars on the sides to restore the original shape. Other uneven weld scars were machined with a lathe, and he used a ball-shaped grinding head on a straight grinder to repeatedly grind the internal curved surface until the balls tested smoothly. When the inner ring surface weld scars were uneven, the master used a threading tool to gradually smooth them, making subsequent grinding with the straight grinder easier. Although inner weld scars do not affect bearing rotation, the internal diameter and smoothness must be restored for installation. After repairing the inner and outer rings, the master's work was not yet finished. The removed balls needed to be reinstalled. The repair shop had custom-made tools for removing the rivets from the cage and reassembling the balls. Enough space was created using a clamp to fix the inner ring on one side to fit all the balls into the cage. Since the inner ring needed to be sintered, the master used the lathe chuck for alignment. With continuous pressure from the chuck, the bearing resumed regular rotation. To prevent the balls from clumping together, the master used the cage spacers to arrange the balls evenly. After removing the rivets during disassembly, the cage was resecured by hammering 8 new rivets, completing the repair of the cracked bearing. How do you feel about the Pakistani master's repair of the tractor bearing? If you were to score it out of 10, what would you give it?